Determine the oxidation number of each element in each of the following species. Now, we talked a lot about oxidation numbers, and I think so there's understanding involved and there's applying involved. So applying is actually a lot easier than anything else. What you can do is just simply create an equation to find the unknown oxidation states. So let me try making some lines here. Okay, that's a terrible line. Let's undo that. Start making neat neat lines, and we'll try figuring out the oxidation state of each of these. Now, let's say I don't know the oxidation state of sulfur in the first one. Well, I don't know that, so I have to calculate it. Sulfur in the second one and chlorine in the third one. Just to make everything easier for me, I'll first make the equation using small letters of whatever these are. So I'll use a small h for the oxidation number for H and a small s for the oxidation number for S. So H2S is essentially 2 hydrogens. I don't know its oxidation state right now. I can look at the periodic table or anything. Plus 1 sulfur. Overall, it is equal to 0, right? Not an N, it's an H. Okay? Now, each hydrogen, if I look at the periodic table or if I remember from my memory, each hydrogen will have an oxidation state of +1 or a charge of +1. Sulfur I have to find out, so it's my unknown. I could call it X. Let's just call it S. S equals to -2. The oxidation state for sulfur is -2 or 2 minus. Let me fix that. Here it is, 2 minus. For H2SO4. Now, my method, how I'm explaining it, really shines here when you have a big equation, right? So, let's get a different color out. Let's see how orange looks. So I have 2 hydrogens. No, let's make it small, and I don't really like orange, but let's continue anyway. Plus 1 sulfur and 4 oxygens. I'm keeping it in a bracket with a hat, so you know it's oxygen and not 40 or 4 times 0. Is all equal to 0. So 2 hydrogens is 2 times +1 plus S plus 4 times -2. Simplifying, I get S minus 6 equal to 0. S equals to +6. Right? S is +6. Easy, right? Not too difficult. It's just form a quick equation looking at the constituents and solve. Let's try the last one. It's KClO4. I want to try black this time. Or let's go with red. Probably doesn't match too well. Anyway, small k plus small cl, sure. That doesn't look like a cl. Cl, sure. Cl, I guess. Plus, again, 4 times oxygen with a hat because it's, fancy. +1 plus my unknown. I don't like Cl right now, so I'll just call it X, right? Excuse my quick change of character here. 4 times -2 is equal to 0. And this is -8, 1, +1. I'm just rearranging it for ease of mind. And all of this should equal to +7. Not -7, right? It's +7. Okay, easy. I hope you guys understand this. Let's move on to the next slide. And this is similarly a lot of those questions again. So let's try doing it. Let's be quick about it. P2O5. So for P2O5, my equation is, I'm going to use black this time. Let's see how that looks. I have 2 P's and 5 oxygens. Hey, this looks pretty good. All equal to 0. Oxygen, not 5 times 0, right? It has a hat. It has a hat on it, right? It has a hat. All right, so 2p, it's my unknown, right? So I'm not going to use the periodic table to find this out, but I can use the periodic table to find iska charge out if I don't know it. 5 times negative 2. This is a 5. I should kind of fix that. Minus 2, 0. And this is negative 10. Yeah. And this is 2p. Yeah. And so it's 2p equal to positive 10. Yeah. And p equals to positive 5. Yeah. Right? So p is equal to positive 5. I hate that 5. I'm going to change it. ठीक है. I don't like that 5 either. Aww. Life isn't fair. ठीक है. Next question. This is an interesting one. देखिए ना, अब तक हम बोल रहे थे overall charge is 0, overall oxidation state is 0, so we set it equal to 0. Is the overall charge equal to 0? No, it's not. Can we apply the same math to it? Yes, we can. Do we have to tweak it? Yes, we do. What's the tweak? I don't know. I do know. So the tweak is, because the overall charge is 0, we set it equal to 0. If the overall charge is not 0, we'll set it equal to not 0. What will we set it to? Whatever the charge is. So let's try doing that. It's not H. SO4 2 minus. ठीक है? And I should stop doing that, right? SO4 2 minus. So S is my unknown. It has 4 oxygens with my hat on top of oxygen. Okay, this is probably not best practice, right? To put a hat on oxygen. Don't copy me. I'm just doing it so you guys know what I'm talking about. And no one's confused 4 times 0 is negative 8, right? I'm not defying maths here. ठीक है? It's all equal to negative 2. Why? Because the overall charge is negative 2, so it has to be equal to negative 2. I always want it to be on Broadway. This is why I break into a song every now and then. ठीक है? S is still my unknown. Positive, negative 8. Haha, you thought I was going to undo, right? Okay. S equals to positive 6. Right? I'm out of space here, so I'm going to pause, I'm going to clean, and we'll continue with more questions. The third question, we're talking about aluminum chloride and a form of aluminum chloride. It's Al2Cl6. Al is my unknown. I'm going to stop using the alphabet things just because I want to show you how different ways you can do it. So I'm going to use the oxidation state for aluminum as, assume it's X, and this I know is equal to negative 1. So my equation becomes X by 2X because there are 2 aluminums plus 6 times negative 1. It is all equal to 0, and 2X therefore equals to positive 6. X equals to positive 3. All right? Okay. ClO2 minus. Tak. I don't think this is a real combine. I'm kind of confused. But no problem. We can still solve it. We're focusing on the solving of the math part of it, right? So it's going to be X for chlorine and negative 2 for oxygen. I'm doing it directly as of now. ठीक है? Is all equal to negative 2. Why negative 2? That's the charge of negative 2. And to solve this, X comes out to be 0. Yeah, that's kind of fishy to me. I don't know. Maybe it is 0. ठीक है? But math-wise, it's all adding up to 0. ठीक है? If there's a problem, it might be just that this is not really ClO2 minus. I think it's ClO just minus, right? All right, last one. Let's change the color for that. I'm going to use pink now. Calcium carbonate. I like this question. And you can use the long way. But remember in the earlier equations, I was talking about how you should know the charge of, like, I think everyone can do this the regular way, right? Each and everything. But here's one thing. The overall charge on this thing is 0. And let's talk about calcium. Let's call it X. If you don't know the charge on it, it's X, right? But carbonate, at this point, you should be familiar with. And to know the charge on carbonate should be negative 2, right? Because you see carbonate as CO3 2 minus. So here's also you can do, why is it 2 minus? Because the individual charges of carbon and oxygen combined are 2 minus, and I can prove it. Let me just prove it here right now. Carbon is positive 4, and the 3 oxygens, each with a charge of minus 2. So overall is equal to negative 2. And that's why it has a negative 2 on top of here. It means the same thing. So you could actually, instead of doing this bit over here, if you're confident the charge on carbonate is always 2 minus, it's all about confidence. You can put it in the equation that is just 2 minus. So what you're essentially doing is, let me erase this. Let me erase a bit more. What you're essentially doing is you're saying the charge on calcium plus the charge on the carbonate ion, which is 2 minus, will all, or oxidation numbers, will all sum up to be equal to 0. And you're taking carbonate as one thing rather than carbons and 3 oxygens. And you can arrive at the same answer. This is probably a better and faster way of analyzing redox equations. This is actually a thing I would strongly encourage. Continuing this, in pink, it's calcium is my unknown and the charge on the carbonate is negative 2, 0, calcium turns out to be positive 1. Accurate answer, you can match the periodic table and you know calcium will always be positive 2, right? Let's do more. Here, I'll use the oxidation state to identify if it's a redox reaction. Now, increase in oxidation state or oxidation number, I'll write it here, increase of oxy number. If its increase is oxidation, and a decrease of oxy number, oxidation number, is reduction. We know this. And then kind of makes sense as well. It's kind of in the name. So iron over here has a charge of 0, oxidation number of 0. It's in its elemental form. Over here, it should have a charge of 2 plus. Why? Because I know sulfur is in group 6, so it has to be, positive or negative 2. So sulfur is negative 2. Negative 2. And sulfur over here is 0. So there's an increase of oxidation number for iron. So it is being oxidized. That's being oxidized. So this is, pink is oxidation. Iron is, Fe has been, I don't have too much room here. Let me erase that. Iron is oxidized, is undergoing oxidation. Let's go with that. Okay? And on the other side, sulfur is being reduced. Sulfur is reduced because there's a decrease in oxidation number for sulfur, and that's reduction. Ammonia, on the other hand, let's take a closer look. This is challenging. I like this equation. I like it. Okay. So ammonia is in group 5, I think. So it has a charge of negative 3. And it's already bonded, right? So it's bonded, so it is negative 3. And hydrogen is plus 1 each, right? So that's balanced. Over here, hydrogen is plus 1. Chlorine is negative 1. And over here, chlorine is negative 1 and hydrogen is bonded to other elements, so it's plus 1, and nitrogen is negative 3. And that makes sense because if I try to add all these numbers up, it's 1 nitrogen plus 4 hydrogens plus 1 chlorine. All of it should equal to 0. Nitrogen is negative 3 plus 4 of each positive hydrogen plus, minus 1, and all of this turns into 0, right? So this is correct. Erasing that. Okay. So what's really going on over here is nitrogen, has it been oxidized or reduced? Well, there's no change in its number. It's negative 3 and it's still negative 3. It's neither oxidized or reduced. Positive 1 for hydrogen. Each hydrogen here and here is still positive 1. They're all 3 here and 1 here. They're all together here. They join, meet up, chai khana pina ke liye mile mein, but they're all positive 1. Even chlorine gets on the chai action, but it's still negative 1, right? None of these are changing their oxidation number. Ergo, none of these are exchanging their electrons. There's no transfer of electrons. This is not redox. There's no redox going on over here. ठीक है?